Well, welcome back. I am Mr. Eicher. Here we go again with Law of Cosines. In the previous video, I showed you where the formula comes from, but in this video, we're going to be solving and actually using the formula to find side lengths and angle measures. So let's get started. In any triangle ABC, so if we have any triangle ABC, it doesn't have to be a right triangle. We have ABC. Opposite of capital A is side A, opposite of B, opposite of C. So there's our triangle ABC. The following equations are true. We could write, for the law of cosines, A squared, the side A, equals B squared plus C squared, minus 2 times B times C, cosine of capital A, the angle A. Like I said in the previous video, notice that the angle that we use here, cosine capital A, is the angle opposite of the side that the equation starts with. Also notice that if we have B and C here, then we have B and C here. We could also write, let's say if we didn't know angle A, but we knew angle B, we could also write the equation like this, starting with the B. B squared equals the other two sides squared, A and C, minus 2 times A times C, and then cosine of what angle do you think? It would be angle capital B. So we'd use that type of formula if we just know this angle B. We'd start our formula with that side opposite of B. And if you haven't guessed yet, we could write one more. We could start with the side C. C squared would be the other two sides, A squared plus B squared, minus 2 times A times B, cosine of, you guessed it, capital C. So all those equations are true. Thankfully, you don't have to use every single one on a triangle. You just have to figure out what angle you know and then base your equation off of that angle. Another helpful formula to, let's say you wanted to solve for a particular angle. These formulas, as I've written them, are helpful if you're looking for side length, A, B, or C. But let's say you wanted to solve, let's just say this equation, and you wanted to solve for angle A. So we'd have to isolate cosine of A. So if we subtract these two terms from both sides, we would get something that looks like this, A squared minus B squared minus C squared, and that would equal negative 2BC cosine A. And then again, we're trying to isolate this cosine A, so we need to get rid of this stuff. And since that 2BC is being multiplied to cosine A, we divide both sides by that amount. So we would have divide by negative 2BC, and that would equal cosine A. Maybe I'll put the equal sign down here. And then if you wanted to finally solve for angle A, you would do the inverse cosine of both sides. We can clean this up a little bit. We usually don't like negatives in the denominator like that. So if we change that, each sign in the numerator will flip. So we would have something that looks like B squared plus C squared minus A squared divided by 2BC, and that equals cosine A. So this is the formula you could use if you're looking for an angle A. You'd take the two sides, B and C, you'd subtract the side opposite of angle A, and then you divide by 2BC. So that's a really helpful formula. When can you use this law of cosines? Well, you apply the law of cosines when you're given two sides and one other piece of information. Maybe you're given the third side, so you know all three sides. That would be a side, side, side situation. You know all three sides. Or if you have a side, the included angle, and another side. So something that looks like, you know that this is 9 and this is 11, and then this angle is 40 degrees. So that would be a side, the included angle between the two sides, and then that third side, or that second side. You can even use the law of cosines in a side-side angle case, which would look like this. You have a side, and the non-included angle. So those are the situations that you could use. Particularly, we focus on these two, but occasionally we could give you a side-side angle that you could use the law of cosines for. But there's another approach that you can use for side-side angle as well. So basically, if you don't have a side angle pair, then you would use the law of cosines. If you have a side angle pair, then you could use the law of sines. Or if it's a right triangle, you could use the SOHCAHTOA right triangle trig ratios. When looking for an angle, always find the largest angle first. You can get into some issues with a ambiguous case, is what it's called. But if you start with the largest angle first, you can avoid that. Let's take a look at an example. We're going to solve this triangle SMH, shake my head, SMH. So we'll call this S, we'll call this M, and this H. Doesn't particularly matter what goes where. So S is 57 degrees. M is 18, so opposite of the angle M is 18. And then opposite of H is 24. So notice here we have a side given, the included angle, and another side. So we would call this a side angle side case, so the law of cosines can be used. Also notice that we do not have a side angle pair. We don't know the side opposite of 57, our angle. So we don't have a pair. We don't have a angle side angle pair. If we did, we could use the law of sines. So let's set up a law of cosines formula, one of these guys up here that we have. Now you'll notice there's no A, B's, and C's, but the general idea is if we know this angle, 57 degrees, we should start by finding this side S. So when we write our law of cosines, I'm going to write number 1, because we have several steps to do here. Number 1, we're going to start with our side S, and then we're going to write the other two sides squared, 18 squared plus 24 squared. And then we're going to write 2, based on the formula, times 18 times 24 times cosine of the angle 57 degrees. So this is the law of cosines, and it's really nice when the law of cosines, you're solving for this angle. Basically, if you are very careful how you type it in, you can type all of this in at once in your calculator and hit enter. Also make sure you're in degree mode on your calculator. So if you'd like to pause the video and solve for S, make sure you can use your calculator correctly. You can do that now. I get S squared equals 429.4318738. That's S squared. We just want S. So when we take a square root, we get 20.723. We'll round to 3 decimal places, put a box around it. It's easy to see on the page that way. And I'll even write it on the triangle here so I remember what the value is, 20.723. Just to check my work, the 57 degrees is probably not the largest angle. It should be H, it looks like, is the largest angle, which 24 is the longest side opposite the largest angle. Now from there, I'd like to use the law of cosines again to find an angle now. On the first case, we used it to find a side. Now I'd like to use it to find an angle. Now you could use the formula that we had above, this formula up here. So if you'd like to pause and try to use that formula right there to find one of the angles that we're looking for, you can do that. But I'm just going to write the general law of cosines formula and then solve it so you can see what that looks like. So number 2, I'm going to solve for H. So if I'm going to solve for H, I need to start with the side opposite of H in the formula. So I'm going to start with 24. The other two sides, we have 18 squared plus a 20.723 squared minus 2 times 18 times 20.723 cosine of the angle I'm looking for, which is capital H. Now, I wanted to write it this way because this is the more complicated law of cosines to solve. We have to solve for H, and it's stuck over here. We can't just plug everything in our calculator and go. I guess we could if we try to use this formula. But to solve this, we would subtract 18 squared from both sides, subtract 20.723 squared from both sides. So let's do that. We would have 24 squared minus 18 squared minus 20.723 squared. We get a negative 177.442729, and that equals 2 times 18 times 20.723. 2 times 18. So that equals negative 746.028 cosine. Just to focus you, let me put a box around that. That's what we have so far. Again, we're trying to isolate cosine A, so we need to divide both sides by this negative 46 number, negative 746. When we do that, we have negative 177.442729 divided by negative that answer I got, and I got 0.2378499.587 equals cosine H. And then finally, we can do the inverse cosine or arc cosine to both sides. So second cosine of that answer, and we get 76.2 degrees. 26.2 degrees. So we can write that 76.2 degrees for angle H. And then our third step, we don't need to use the law of cosines or sines or anything from there. We have one angle and we know the other two, so the measure of angle M would be 180 minus 57 minus 76.2, which equals 46.8. 46.8 degrees. You can see that we have solved the triangle. We know all three sides, check, and we know all three angles, check. That's what we mean when we say solve the triangle. On the second page of the notes, what I would like you to do as part of your try this, now this says solve the triangle, but just to make sure you get the idea of how to use the law of cosines, I'd like you to only solve for one part. So let's say this is triangle ABC. Angle A is 57 degrees. Opposite of angle A is 8. Opposite of C is 4. This is a side angle side case, which allows us to use the law of cosines. So what I would like you to do as you try this is to find B. It would be good practice to finish the entire triangle, but as a try this, I'll just have you solve for B. For number 2, we have triangle Ike, I-K-E, and opposite of I is 7, opposite of 9, opposite of K is 9, and opposite of E is 12. What I would like you to do, oh, by the way, this is a side, side, side case. We're given the three sides, so this allows us to use the law of cosines. You would not be able to use the law of sines, or you can't use right triangle trig because it's not a right triangle. So I would like you to find the measure of angle E first. Angle E is the largest angle since it's opposite the longest side. And as we said on the first page of the notes, it's best to start by finding the largest angle first. So as to try this, I'd like you to find the measure of angle E. And then I'd like you to also find the measure of angle K. And we might as well have you find the last angle because that's pretty easy once you find the other two. But you'll have a try this to complete number 3. And then lastly, I want to help you with the diagram and then you'll solve it from there as a try this. It says 2 airplanes leave an airport and the angle between their flight paths is 40 degrees. An hour later, one plane has traveled 300 miles while the other has traveled 200 miles. How far apart are the planes at this time? The picture I'm going to draw is kind of an aerial view looking down at the airport. So if you're way up in the air looking down, God's eye view looking down at the airport, you have one plane that is traveling this direction. You have another plane that is traveling this direction. And the angle between them is 40 degrees. One plane has traveled 300 miles and the other plane has traveled 200 miles. How far apart are they? So we would like to know after 1 hour, how far apart are they, which is x. So This is a side, an included angle in a side, side angle side, that allows us to use the law of cosines, not the law of sines and not right triangle trigonometry. As we try this, I'd like you to use the law of cosines and find the measure of x, which is the distance between the two planes. Thank you so much for watching this video. I hope that was helpful as we saw some concrete examples of how to use the law of cosines to find sides and how to use the law of cosines to find angles. If you have any questions, please reach out to your teacher. Thanks again for watching. See you next time.